Welcome to the Potter Blog site, January 28th, Saturday, 2012. Very disconcerting discovery out. Basically, the weaponization of Fukushima fallout. It's naturally occurring weaponization. And I guess let me go aside for a second and describe what I mean by weaponization. I think most people are familiar with anthrax. If you just took a handful of naturally occurring anthrax spores and you threw them up into the air, and if we were doing a vulnerability analysis, as you threw those naturally occurring anthrax spores up in the air, there'd be a kill probability of 1, which means 100%, probably within 100 meters downwind. And after that, the PKs would drop off. Now, if it were weaponized anthrax, if you threw that same handful of anthrax into the air, the PK values would probably remain at 1 for maybe 100 miles downwind. The difference is in weaponized anthrax versus regular naturally occurring anthrax is the anthrax, each spore is basically free to float in the air by itself. It doesn't stick to the other spores. So it's a much smaller surface. It can travel much further in the wind, and it can get much deeper into the lungs. Well, in essence, we've had something similar occur here with uranium now coming out of Fukushima, and that's the formation of fullerenes. And what you see here in the image in front of you looks like the structural skeleton of a soccer ball, and that's in essence what this is. And this fullerene is made of carbon. Each one of these black dots here is a carbon atom, and each one of those tubes connecting it are the atomic bonds making the connection. And if you notice, the inside is hollow. That means that this package here can actually deliver. There can be other atoms inside of here free floating that this fullerene here can deliver. Those are called endofullerenes. Now, what makes this troubling is these are nanoparticles, which means they're extremely small, and in this case pretty strong too. Now, the discovery came here in a story just recently released, and these people here, I believe, deserve an award for thinking of these possibilities and doing these tests. Now, the key thing to see through here is, basically I'll read the abstract to you. The Fukushima Daiichi nuclear accident brought together compromised irradiated fuel and large amounts of seawater in a high radiation field. Based on newly acquired thermochemical data for a series of uranyl peroxides, compounds containing charge balancing alkali cations, here we show that nanoscale cage clusters, and that's what you just saw in the image before, on nanoscale cage clusters, containing as many as 60 uranyl ions, bonded through peroxide and hydrogen bridges, are likely to form in solution or as precipitates under such conditions. These species will enhance the corrosion of the damaged fuel and this is where it gets to be critically important, in being thermodynamically stable and kinetically persistent in the absence of peroxide, they can potentially transport uranium over a long distance. Well, there's a lot more to it than just that. But as people look back 50 years from now on the cancer rates and the deaths associated with Fukushima, this study here will probably be the key indicator in a significant quantity of those cancers and deaths. Now, what's happened is that uranium has formed this structure. So what we have now is a very small, cohesive structure of uranium atoms that basically don't stick to the other uranium atoms that are not inside that are not made of the structure. So they're free-floating nanoparticles that are stable in the water, stable in the air. It's the equivalent of the anthrax model, which is these things are small, nanoscale, persistent, can spread over a large area. And what that means is that every simulation model showing the transport and deposition of fallout from Fukushima is potentially wrong. Fallout's in a much broader area. It's transported much more easily. But even worse is the effects of these nanoparticles when they reach the body. Here's a chart for uranium. It shows the lifetime cancer risk, and basically what all this refers to is the reference dose. And a reference dose is the quantity of the contaminant, in this case uranium, that is required to produce an effect. Well, since these particles are so small, they have a much easier time getting inside deep into the lungs. If you swallow them, they're more easily ingested and absorbed through the intestines, and they're much more likely to penetrate blood-brain barriers. Not only that, in the case of uranium, uranium is a bone and kidney seeker. And so what will happen is these uranium atoms now have a much, let's call it a autobahn to your inside of your body. Now, if we go back and look at the structure of this fullerene, inside here can be trapped plutonium atoms, cesium atoms, any number of whatever's in the fallout, in the water, or in the air as this fullerene is being created, can be inside that. Now, so let's take, for example, plutonium. Say there's plutonium inside this fullerene, this uranium buckyballs, as they're often known, named after Buckminster Fuller, the person who popularized the geodesic dome. If there's plutonium inside this, usually plutonium often is described as being only harmful if inhaled. Some people claim you can drink plutonium because it'll pass through your body rapidly. Well, plutonium inside of this fullerene, making an endofullerene, if this gets ingested, the uranium will pull this towards your bones and your kidney. In essence, it's a cruise missile for the plutonium inside of it, or whatever else is inside of it. And it gets even worse. Now, if you've got a radioactive particle inside here, surrounded by other high atomic weight radioactive particles, and you have a decay, there's a possibility of localized fission in here. And even worse than that, since these particles are small, let's say they're outside the body, they go high in the upper atmosphere. So when we have solar storms and solar proton events, especially proton events where the geomagnetic structure of the Earth alters enough that it's not all directed, that not all the protons are directed towards the poles, these types of structures provide a much greater target for spallation. So all around, this thing is just people don't realize how bad of a news this is, and it's likely to be underreported how bad of a news this is. But if you're a reporter in Fukushima, or you're anywhere around Fukushima, and you're relying on an N95 or a surgical mask to keep you safe, yeah, you're hosed. I mean, this type of contaminant requires at least a P100 respirator, if not a self-contained breathing apparatus. And if you follow the Potter blog site, one of the things we've stated before is we believe that a good portion of the corium is in the groundwater, and at least since August. Now we've detected short half-life radiation that bears out that. But there's a good news aspect to that, and these things function in the presence of salt water. So if the corium is functionally being cooled by groundwater, then potentially there's a lesser likelihood of the current formation of these fullerenes and endofullerenes. But nobody really knows what the conditions are like in several of those reactors. But that would mean, if that's the case and it's all being cooled by groundwater, then the majority of these buckyballs, uranium buckyballs, were formed within the probably first 6 months of the accident. But now where it gets incredibly even more concerning is the spent fuel pool that people have claimed is on the verge of a collapse at Fukushima pending the right earthquake. That fuel pool, since it's elevated, is obviously still being cooled by salt water. So that fuel pool has got to be forming just buku fullerenes. That fuel pool collapses, and these fullerenes spread. I mean, that means these speedy models that Japan they use for evacuation purposes will be not good enough. And if you're living in Tokyo, I'd suggest that you have a basically a gas mask ready, P100 military type gas mask. I think there's a 3M type 64 filter that might do the job. But as I said before, people don't begin to even understand how concerning this information is. This is the type of thing where people look back in 50 to 100 years and they'll just be in utter amazement about the salt water being thrown on these reactors and continuing to be thrown on these reactors. Hopefully it'll spur the improvement or some thought of improved emergency or improvised cooling mechanisms for these type of situations. Very troubling indeed.